Hi everyone, today we're doing a different lesson again. So it comes from Skew the Script and it's not from our packet because again, what was in our packet, it wasn't ideal for a remote setting. And so make sure you got this new lesson from Canvas, and you can also go through the Desmos activity linked into Canvas that goes along with it for getting a lot of these blanks filled in, and then some really clear explanations I believe are in there. What I'm going to do is go through, so pause this video and do that if you haven't. You're going to work through the whole 4 pages. It's all doable through the Desmos activity. Then when you come back to the video, I'm just going to debrief a few things. All right, so basically the first 2 pages should have been a review overall of what we've learned already. One thing I want to explain is this data set. It's kind of funny about OkCupid and whether their men are lying about their height and incomes. So one thing just to make sure you understand about this table is they sorted them into shorter than median, taller than median, less than median earnings, or more than median earnings. So remember, the median, it should be 50% below and 50% above. So if that's not the case, then that's where we see that there may be some dishonesty going on these profiles. You can look more at this data if you'd like to look more into it. And there's also a previous Skew the Script lesson from 5.2 that you can also follow along with if you'd like to see anything more in depth about this scenario. So this is all review. I'm just going to pull this up, make it a little bit bigger so you can pause and make sure you have all these answers. The Desmos also gave you these answers. Same thing with this page. You can pause to get them. But I do want to kind of go over the bottom here with the independent versus mutually exclusive. People often get these phrases mixed up. So remember, independent means one does not affect the other. And mutually exclusive means 2 events that cannot happen at the same time. So if they're mutually exclusive, then that means one event happening prevents the other event from happening, which definitely affects it. So they're not independent. So a lot of people think they mean the same thing, but this is a good example to show how they're not. If they're independent, then P of A would equal P of A given B, but they don't, so they're not independent. Hopefully that makes sense. Now, this stuff is all pretty new, and so we should have the formal multiplication rule. We're just going to kind of box this in, and then we actually already learned for independent events how that works. I do want to show you that this rule comes from something we already know. We already know this rule. So if we solve for the P of A and B, then we just multiply this across, and it gets us P of B times P of A given B. And that is the same formula. And so they equal the same thing. I know it looks a little different, but they represent the same thing. And then we also have this one, which we can manipulate to make it work out. If P of A and B equals P of A times P of B given A, for independent events, this equals P of B. That looks confusing. And so that is where this formula comes from, which we would have already seen probably in our last lesson. And then just the intuitive multiplication rule. There's all these rules and formulas, but basically and means multiply. Account for the dependent events by using the right formula. There's 2 options. And I'm just going to add and equals multiply or equals add. Those are some intuitive things. Now the tree. All right, so hopefully with this dream school example, you were able to see the tree diagram in Desmos and how it worked. I'm just going to debrief a little bit about the behind the scenes of it. So first, as you see that we already have H and HC. And so these branches add to 1. That's how I got this. So I'm going to put P of H right here. And then this is P of not H. And so remember, that's just 1 minus P of H. And you can have more than one branch, more than 2 branches or anything from a tree diagram, but just the whole set of branches should add to 1. So then the next one, this A, this is not P of A. This was P of A given H. So it was admitted given that you have that higher than average ACT, which makes this one A, not A given H, I mean. So these both came from the H branch, which is why they're given H. So we can label these others the same way. Here we have A given not H, and here we have not A given not H. And so basically what you need to know is this whole middle set of branches is all conditional. And so they all are based on H or not H being the condition. And then look at this, we multiply through the branches is how you finish a tree diagram. And so this is going to be P of H times P of A given H, which we know from our formula up here that that equals P of A and H. And so here we can just kind of show all of this. P of, I guess I could write H and A is actually better for this one, but they're the same thing. So I'm not going to change it. And this one will be H and not A. Here we have P of not H times P of A given not H. And last one is not H and not A. And remember, that is neither that we've seen. And now that we have all of these written out, we could really make a Venn diagram or a tree or a two-way table from this. But we wouldn't want to do that until we have all of the ands at the end. And so the main thing is that all of the end are the ands. So we have conditional in the middle of the tree and at the end. And then these should also all add to 1 because it's all possible outcomes for the scenario. Okay, so if we come down here and look at these questions, we have number 1, find P of H and A. And I wrote A and H, but H and H are the same thing. And so that was just that number from the top of my table. So again, it was P of H given A. No, I'm getting this backwards. We got that by doing P of A times P of H given A. Oh, wrote it backwards again. First, you have the higher than average ACT or SAT score or GPA, and then you're admitted based on that. So that's how you remember how to do it. We already did that in the table. And then for this next one, P of A, was just finding all the places where there was an A. So that was here or here. And so the plus is or. I'm going to use the red for that. So you can get admitted with a higher than average scores or lower than average, but you'll still get admitted in either case. So or. And then this here is the given. And so we have P of H and A over P of A. Then that formula comes directly from the previous two questions. Just had some intuitive rules. I just want to show you where everything kind of comes from. So first, we're looking at these 5 intuitive rules. We have the complement rule, or means add, but make sure you don't add anything twice. Given means divide, and means multiply, but make sure you use the right formula. And then anything that's at least 1, it's always easier to do 1 minus none. So those are some just intuitive rules that you can use. These on the right are the formulas that you get on your AP exam. So remember, this is or, and this is and this little guy is not. And then a couple of things can come from this. So if we have mutually exclusive, then P of A and B is 0. Don't forget that. And then if we have independent, then P of A given B equals P of A. And this can be manipulated to give you the multiplication rule. So you can just multiply that across to get the multiplication for P of A and B. So that's a couple of things from there that are tied to the intuitive rules. But again, the intuitive rules are better to just know. And so hopefully you were able to do the card sort on Desmos and match these up properly. But if not, here you are. And then this discussion was just for you to check out. It looked like if you look at the low earners only, their results were about 50-50. So they did match the median rule that we had used to sort them into groups in the first place. And so they seem to be more honest than their high earner counterparts. Okay, so let's do this right here. Pause, write all these rules down, and then we will do the check your understanding. So you can go ahead and pause the video now, copy these notes into your box from your original activity, and then try the check your understanding, and we'll go over the answers. Okay, so give the check your understanding a try if you haven't, and then we're going to show you the answers here. Now, I don't want you to get always so complicated on the tree diagram as I did in the notes. So this is just what one looks like. I do want you to always multiply through the branches. For a complete tree diagram. Remember, this is and these are given. So then these should add to 1. And then each set of branches adds to 1 as well. So then just so you see where everything comes from, I'm going to use the purple here. P of T, there's a T here and a T here. And so that's where those two numbers, and it's just, you can have a tablet from California or from Texas, and so the or is where we add. And then given that someone, and so I can just show you the formula for this. Oops. That's going to be P of California and tablet over tablet. And so we have the tablet from number 2. We have the California and tablet from the tree diagram, and that's where those 2% come from to get us a final answer of 0.3. And then the last one is that at least one. If we select 4 computers at random from the distribution center with replacement, what's the probability that at least one of them is a tablet? So I kind of went through my thought process here. First, we want to find not a tablet. So there's a 40% chance that it is a tablet, or sorry, a 60% chance from number 2 that it is a tablet, and so a 40% chance that it's not. And if we're getting 4 computers and none of them are tablets, then that is what this rule is right here. 0.4 to the 4th, because it's like 0.4 times 0.4 times 0.4 times 0.4, and the with replacement means independent. Actually, I want to write that last thing in red. So it's like a note. And so that's why I'm just doing P tablet times tablet times, or not tablet times not tablet times not tablet times not tablet. And 1 minus that will get, that's a much faster way than trying to think of all the other outcomes. So here's the overall answers. Make sure you email with any questions, and thank you so much. Have a great day.